All right, I think it's time to start here. Welcome, everyone. I am so thrilled to be here in front of a live audience after 2 years, and I'm so glad you're all here with us. You're here to talk about reliable scalability, how Amazon.com scales in the cloud. My name is Seth Elliott. Just a little bit about me. I'm with AWS now. I'm the reliability lead for AWS Well Architected and been with AWS for a couple of years now. But I spent the prior 8 years with Amazon.com. And so, when we talk about Amazon.com in this case, we're talking about the site you buy stuff from. We're talking about, where you go to buy a Kindle or a book or even, download or stream a movie from Prime Video. So that's the Amazon.com we're talking about today whenever we refer to Amazon.com. And I've had several roles. I've been on the Prime Video team when it was founded, way back when in 2008. I've been on the content ingestion team, Amazon Fresh. But my most recent role before I transferred to AWS was with the team working across the entirety of Amazon.com with our thousands of developers of how they develop and implement in AWS. And in that role, I partnered with our AWS support team. We're Amazon.com. We, back then, is a customer of AWS. And our support team, my counterpart on that support team was Kieran. And Kieran's here to talk with you also today.
Thank you, Seth. Yes, hi, everybody. My name is Kieran Kavanagh, and I'm a Principal Solutions Architect at AWS. I currently specialize in machine learning, but prior to that, I worked as a generalist SA on the Amazon.com account, as Seth was saying. So back then, Seth was actually a customer of mine. We've been working together for quite some time now. And where better to begin our journey today than at the actual beginning. What you see here is the Amazon.com books website from 1995. And you can see it's not quite as advanced and feature-rich as the website that Amazon has nowadays, but this was pretty standard for the mid-90s. What is impressive here is that they already had 1 million titles, so they were already Earth's largest bookstore. And let's take a look at the architecture that was used to serve this website to customers. Started off pretty simple. What you see here is a customer coming in over the internet. The first thing that they interact with is something called Obidos. That was the web server layer. And that was a single monolithic service. We'll talk a little bit more about that later. And it connected directly to a single Oracle database in the back end, which was called the Amazon.com Books database, or ACB database. And this database had everything that was needed to do business on Amazon's website. You had a table for all of the customers. You had a table for all of the inventory. And you had a table that tracked what customers were purchasing from the inventory. You can see here also that Amazon started off with one distribution center for sending out packages to people. And also you'll see this thing called the credit card motel. What's interesting about the credit card motel is that once you checked a piece of credit card information in there, you could no longer humanly read it back. The only piece of code that could access that credit card details was a small piece of code that actually connected to the banking institutions to make a purchase when somebody's purchasing something on Amazon.com. So security was built in from the very beginning. It was a major priority even from the very first version of Amazon's architecture. And Amazon wanted to get big fast. What you see here in the top right-hand corner is a picture of a t-shirt from a company picnic that took place back in 1997. And you can see the slogan says, "Get big fast, have another hot dog." That is one way of getting big fast, but that's not what we're going to talk about today. We're going to talk about scaling out the architecture. And just beginning first with a quick definition, when we talk about scalability, we say it's the ability of a workload to perform its agreed function when the load or scope changes. So if you keep getting lots more traffic onto your system, you want to make sure that your system scales up and that it continues to do what you expected it to do. Now, before we dive into how Amazon scaled out their architecture, I want to first ask you to take a moment to think about, with pretty much any web-based architecture, what is one of the first components in the architecture that becomes a scaling concern? Yes, you guessed it right, the database layer. And that's exactly what Amazon started to scale out first. One of the first things they did in this regard is they created a separate database called Web1 that was just for orders. Now, why is this important? When you think of any e-commerce platform, the ability for people to make orders on that platform is one of the most important things that the platform can do, right? That's one of the most important functions. And so there was this dedicated database and a dedicated path for people to make orders, so that if other stuff was going on with the central ACB database, the orders had its own separate workflow that wouldn't be affected by any congestion there. And this orders table then was being synchronized periodically back to the central ACB database. And as Amazon grew over time, they added more distribution centers, of course. If you're sending out more and more packages to people, you have more and more customers growing. and you need more distribution centers to meet all of their demands. And each distribution center had its own dedicated database. So this is another way that they scaled out the database layer. And this continued to grow. The distribution centers grew to about 175, and the number of databases grew to more than 300. These were all Oracle databases, but they've all recently been deprecated, or they've all since then been deprecated, and now Amazon is using all AWS database technologies instead. So the final Oracle database was shut down by Amazon's retail business back in 2019. And now that we've talked about scaling out the database layer, what is the next component in our architecture here that we need to think about scaling? Yes, you guessed it right again, the application layer. And this is the Obidos piece that I talked about here. This was the single monolithic service that contained all of the business logic required to do everything on Amazon's websites. And every new feature that was being added was all being added to this single code base. So when Amazon added one-click shopping, for example, that was added to Obidos. Every bug fix, every feature was all being added to this single code base. And Obidos grew a lot over time. In fact, at one point, it got to the stage where it was taking 12 hours to build it. So if you wanted to make a change and you kick off a build, then you would either go about your day, or maybe it's in the evening time, you go to sleep for the night. You come back 12 hours later, and you just hope and really hope that what you intended to do worked, because otherwise you have to go through all of that again. And as you can see, this is not really scalable in the long term, and this is not really scalable, especially as you are employing more and more developers, and they all want to be adding things to this code base. So one of the first things that Amazon did in this regard is they started to break it out into separate components. The first one that they broke out was the customer service. And this was a service that was used for interacting with customer information. So there was a dedicated customer database that was created. So they're scaling out the database layer in this case again. And also the customers were regionalized. So there was a different database for different customers in different regions. What you're seeing here as an example is the CustNA database is customers in North America. And if a new customer wanted to sign up, they would interact with the customer service in order to get their details into that customer database. And also if an address was needed for printing a shipping label, the customer service would be called to fetch that address. So this was one of Amazon's first steps towards a service-oriented architecture approach. And at the very beginning of the customer service, you could almost say that it was a microservice, because even though microservices weren't really a thing back then in the industry, people were talking about them a lot. But the customer service started off with a really dedicated set of functions and a dedicated database, and it just had a very simple set of operations that it was doing. Most of its APIs were wrappers around SQL calls into the database. But this then grew over time, and so people started adding more and more to the customer service because they were reluctant to be adding more and more to Obidos. And the architecture continued to scale, and if we look at some details around the kind of growth that Amazon has seen in the past few years, we're having a look at some details here from Prime Day earlier this year, where 175 million items were purchased by Prime members just during that period. So that's a lot of commerce that's going on Amazon's website nowadays. And if we look at what that means in terms of AWS service usage, what kind of scalability they've achieved there, during Prime Day this year, Amazon DynamoDB handled about almost 90 million requests per second at peak. And if we take a look at another example here, Amazon CloudFront processed more than 290 million requests per minute during that time, totaling to 600 billion requests during Prime Day. So that's some pretty serious scale that they've been achieving here. And now let's take a look at what Amazon did to scale out their architecture to handle this kind of growth. Well, it turns out that after that first change that they made, this first thing of breaking out the customer service, they didn't need to do anything else after that. That solved all of the problems from there onwards. Just kidding. This is actually what Amazon's architecture looks like nowadays. It's an extremely vast and complex web of microservices. And this is an actual real picture, by the way. This is a picture from an internal tool at Amazon that tracks deployed services and their dependencies. And we can even zoom in here and look at one microservice that's connected to about 400 other microservices here. Everything I've talked about up until now has been around scalability, but this presentation is called reliable scalability. So let's talk about reliability for a minute. Starting off again with a definition, we say that reliability is the ability of a workload to perform its required function correctly and consistently. And when we couple that with the scalability aspect, it means that no matter how much your system scales, you want it to have the same service level agreements, et cetera. You want to have the same kind of experience for your customers. This is the reliability aspect. And reliability is such an important part of pretty much any systems architecture that it has a dedicated pillar in the AWS well-architected framework. The well-architected framework is a collection of best practices that you can use to ensure that your systems are architected to perform optimally. And reliability has its own dedicated pillar. A pillar is basically a category of best practices. And there are 5 in total. We'll be talking mainly about reliability today and also operational excellence. This is where the scalability aspect comes in. All of the pillars are very important. The other 3 are security, performance, efficiency, and cost optimization. All of these are very important for pretty much all workloads, but we'll be focusing mainly on reliability and operational excellence today. And at this point, I want to hand you over to Seth to talk about how Amazon architects these microservices that we've just been showing.
Yeah, thank you, Kieran. All right, yeah. So that was a little bit of a history lesson on Amazon. Now let's dive into how things are operating today. And we'll start off by talking about service-oriented architecture and microservices architectures. Now, for each of these subsequent sections we're going to show you, we're going to tie them into an Amazon leadership principle. Now, Amazon leadership principles are the 16 principles that all Amazonians across the company sort of keep in mind every day when they're making decisions or doing tasks at Amazon. You know, is this the right thing to do? Well, let's refer back to the leadership principles. So this one's bias for action. Speed matters in business. We value calculated risk-taking. So I will hopefully tie it in how a service-oriented architecture, also called SOA, or microservices architecture can factor into that speed and bias for action. And just real brief, just so everybody's on the same page, just a little bit of just the sort of 101 of monolith versus SOA versus microservices. So the monolith is what Kieran was talking about, Obidos. A big binary, all changes go into that binary. Everybody's kind of beholden to that binary. If you want to make a change, you got to hope everybody else's changes don't break you. It's big, it's unwieldy. There are maybe some valid applications for monoliths today, but generally we try to shy away from them. And service-oriented architecture, that's where we take each of our applications and make them a separate service and have them communicating with each other. So you might have a catalog service or even a catalog ingestion service, right, as one of your services, and microservices. Now let's break it down further. You can think about taking those applications and breaking them down into individual components, each a separate service that does its own thing. So for that catalog ingestion service, maybe you have a service dedicated just to taking in merchant data that's being submitted to the catalog and matching it with the existing catalog. That's a single microservice. So that's a microservices architecture. We're not going to make a value judgment between SOA and microservices. They both have a place and they're both good. I'm just going to lump them together and just talk about them together as generally not monolith. And towards that end, when you're using microservices or even SOA, the nice thing about them is the ability to deploy them and scale them independently, right? So if some need more capacity than in the AWS cloud, you can then ramp them up with the Elastic Cloud and supply more capacity to them. Some need less capacity. You can give that capacity back so you're not paying for what you don't need. And the nice thing about AWS is using organizations and consolidated billing, you get to share that capacity between your microservices. So one is scaling down, you release that capacity so another one can scale up. So again, it's just a real nice way AWS helps you keep that efficient. And ultimately, at Amazon, they have 150 million deployments per year. Now, to be sure, not all of these are major features or major functionality, or even customer visible functionality. A lot of them may be just utility deployments, things to get out, get things out there. But still, it just speaks to the culture at Amazon. They have a culture of continuous integration and continuous deployment, and that high deployment lets them. So you can imagine this deployment as this huge stream going out the door, and you could always be putting in the features and functionality you need onto that stream. All right, so let's look at some examples of the microservices architecture at Amazon. This is a page I think you should all be pretty familiar with. It's a detail page. It's a page where you go to Amazon.com or your local Amazon.com, your marketplace, and you can buy stuff. You could look at the picture, you could look at the price, you could look at the reviews, and then you could click add to cart, or as we talked about one-click ordering, you do one-click ordering. So that's a detail page. Now, if we take this same page and look at it using an internal tool that's available within Amazon.com, it might look like this. And I don't know how it's showing up on the big screen here, but each of those little arrows is pointing to a microservice. There's an image microservice, there's a title microservice, there's a stars rating microservice. So what's happening is when you see a detail page, it's making hundreds of calls to hundreds of microservices in parallel, marshaling them together very quickly and displaying them to you as a single detail page. The advantage here is let's say the star rating service is having an issue and it can't show you the star rating. It can still show you the rest of the page, the image, the title, the price, add to cart. It results in much higher availability, reliability, and much higher scalability. Also, when I want to make a change, if I want to change the title feature somehow, I don't have to make a change to a big monolith or big binary. I could just change that one microservice. Here's another example from Amazon.com. Back in 2019, Amazon.com released a new feature called subscription boxes. Subscription boxes, you could sign up to receive monthly a box of high quality items in a certain category, like green kids crafts or kids toys or coloring books or whatever you want, right? There's a whole kind of Marvel merchandise, there's all kinds of subscription boxes. And they wanted to launch this in 2019, and this is the architecture for the subscription boxes architecture that they launched. So let me walk you through it. Not that complex, right? You have an API gateway right there on the front. Because it's a microservice, it has to present a set of APIs, so that's how it does it. It's got AWS Lambda, which is the AWS serverless functionality where you could deploy, and that contains the business logic. The business logic is deployed to Lambda, so it's able to execute the business logic serverlessly. DynamoDB, which is the NoSQL database, where it's basically storing state, like who's subscribed to what and on what date are they expecting to get their merchandise, that kind of stuff. And the S3 bucket is pretty much there for logs. Important, but just putting it on there to keep the logs so that they could do the monitoring and go back through the logs, et cetera. That's the architecture. Matter of fact, the team that put this together comprised of 3 engineers, and they call it a nanoservice. They said it's not a microservice, it's a nanoservice. It's that small. But ultimately handles millions of events per day. So how could this be? How could I show you that great, cool new feature, and yet that's the architecture? Because that's the key about microservices. Does this service have to worry about pricing? No. Does this service have to worry about the catalog? No. It calls the catalog to get information. Is this a kid's craft? Is this a coloring book? Is this highly rated, right? Does it have to worry about fulfillment, sending the merchandise to the customer? No, it just has to worry about which items they're going to get, and it tells fulfillment to do it. That's the key to microservices. It does one thing and one thing only and delegates everything else to the other services around it. Ultimately, all right, so this is, we're going to show several of these slides today. So what this is, Kieran talked about the well-architected framework. Well, another part of the well-architected framework is the well-architected tool. The well-architected tool is free to use, available through the AWS console. And what the well-architected tool does is let you take those best practices that are described by well-architected and review your own workloads, your stuff built in AWS, your own cloud-based workloads, and say, am I or am I not doing these practices? And based on that, it will make improvement recommendations to you. And it's done in a Q&A format. So the question is along the top there. In this case, how will you design your workload service architecture? And you can see in the underlined section, it's talking about SOA and microservices architecture. The best practices are the little checkboxes. So in this case, the best practices is choose how you're going to segment your workload. Are you going to segment it big, small, microservices, SOA? And also make sure that segmentation maps to the business domains. So those are the best practices that Amazon is exhibiting in the examples I showed you. And we're going to refer back to the well-architected tool to show you the well-architected best practices. Okay, for the next section, I'm going to have Kieran talk to you. All right.
Thank you, Seth.
Sure.
Okay, so now that Seth has talked a bit more about how Amazon architects their systems in terms of microservices, let's now talk about how they review and test those systems. Because of course, once you design a system, you don't just launch it into production and see how it goes. You want to review and test things before launching to ensure that what you've designed will behave the way you want it to. And this is in alignment with the leadership principle on insisting on the highest standards, where leaders continually raise the bar and drive their teams to deliver high quality products. Now, it's important for me at this time to introduce the concept of mechanisms, which is a really important part of Amazon's culture. This goes back to a quote from Jeff Bezos from many years ago when he was talking about if you want some kind of real sustainable change in your organization. He said that when you ask for good intentions, you're not really asking for a change because people already had good intentions. Now, most people you meet, they try their best to be a good person. They try their best to be a good employee, to do well in their job. If they architect a system, they hope that that system performs as optimally as possible. So if you want to improve something, and you sit down with your team and you say, hey, everybody, let's make this thing better. And everybody says, yes, let's do it. That's not enough. You need some kind of mechanism to measure what you're doing, to ensure that you're working towards the goal that you've been setting out. And your mechanism, as you can see here in the graphic, generally a mechanism will take some kind of inputs, put them through some kind of formalized process to produce some kind of expected outputs. And there will usually be tools that are involved in making the mechanism work. You will have to drive adoption of this mechanism so that people actually use it and so that it will be successful. And a really, really important part here is the inspection part of that cycle, whereby you need to constantly inspect your mechanism to see if it is having the intended effect. And if not, then maybe you need to change something about the mechanism. And one of the first mechanisms I want to talk about here in this review and test section of our presentation is the code review process at Amazon. Basically, any piece of code that is intended to go to production needs to be code reviewed, needs to be reviewed by a peer developer. So if you're a developer at Amazon and you want to push a piece of code that is going out to production, you'll need some peer of yours to review it and agree that this will have the intended effect that it's supposed to have, that it is really something that should be pushed into production. And if for some reason you don't reach consensus between the developer, the original developer and the reviewer, then another reviewer will be pulled in, for example. And it's also iterative. So any code review changes that are suggested, they themselves then will go through another code review process. It's also a formal mechanism. It's not a case of just sitting down with your friend on your team and saying, hey, take a look at my code and let me know what you think. Basically, if somebody approves your code to go into production, then they also become responsible for its success in production. Another mechanism that Amazon uses is the principal engineering community. Principals at Amazon are very senior technical leaders and experts in their field. They're seen as exemplary practitioners in the company, and their job, among many things, is to continuously learn and improve their own skill sets, also to educate others and help others to improve in the company. And very importantly, they also need to provide clarity when there's decisions that need to be made under ambiguous circumstances. And there's a few different ways that people can interact with principals in the company. So one way is a principal consult. That's usually something that happens maybe earlier in a project if you have some kind of idea and you want to run it by a senior technical leader and get feedback from them about is that the right way to approach it or not. And then there's also the principal design review. That's a much more thorough engagement whereby you have an actual technical design. You have maybe a technical architecture diagram, for example, that you want to review with a principal, and they will go through it in a lot of detail, looking at all of the different API calls and the overall system, and give feedback on any bits that you may need to change in that system. And one of the great things about the principal engineering community is that you will find experts across the company that specialize in different things. So if you need help with security or API design or internationalization, you'll find some expert who specializes in that can help you. And now that we've talked about some of the review mechanisms, let's move on to testing. And when it comes to testing, we're going to use specific test cases that are used by Prime Video because we want to give you real-world use cases in addition to the concepts that we'll be talking about. One of the first things that we'll focus on in this section is Prime Video's preparation for launching Thursday Night Football. Thursday Night Football was one of the first live streaming sports events that Prime Video supported on their platform. And so they wanted to make sure that everything went well. It's the first time they're doing this kind of thing. But how do you plan and test for something that you've never done before? Well, the kinds of tests that Prime Video used were load testing, of course. They knew this was going to be a big event. They needed to predict how much traffic they were going to expect on their system, and then scale their systems up to that and simulate that traffic and ensure that it can handle it accordingly. There's also performance testing. This is measuring basically how is your system performing when it's running at that increased load. Are things like latency increasing? Are the number of errors increasing? Then there's also stress testing. This is where you go beyond what you expect your system to be able to handle. So you keep pushing more and more and more and try to see if you can find a breaking point somewhere. Then there's chaos testing. In this case, they are introducing specific failure scenarios into their testing strategy and seeing how their system behaves under those circumstances. And this is in alignment with the testing reliability piece under the reliability pillar, specifically around testing, scaling, and performance requirements, and using chaos engineering to test resiliency. Now, no matter how much you plan and test, there will always be things that happen in production that you weren't expecting. One of the first examples I'll show here from Prime Video is when they were streaming a Bundesliga game. This was a soccer match in Europe. And what you can see here on the graph, the two blue vertical lines are the start and end of the game. see these ramp-ups that are happening at the beginning. So you see a ramp-up in streams starting and a ramp-up in people signing up to watch the game. All of this, of course, was expected. Prime Video had planned for this. What was not expected here is this huge spike that you see right in the middle of the game. Now, what happened here? Well, basically, this game happened to get really exciting. It was a game in which two teams with a lot of rivalry were playing against each other. And in the middle of the game, it got really, really heated. And the atmosphere grew a lot. People were posting on social media about it. People were texting their friends about it, saying, you have to watch this game. It's getting crazy. So lots and lots of people in the middle of the game signed up to watch the game. This is not at all what Prime Video was expecting. They were not expecting that in the middle of the game, suddenly a bunch of people would be signing up to try to watch it. So this was an unexpected thing. And another unexpected thing that they encountered was when they released a new episode of a very popular TV show on their platform. And here you can see the ramp-ups happening to when they're launching the episode. All of that was expected. What was not expected in this case was this double spike that happened. Now what happened here is that this episode, as I said, it was a very popular TV show, and a lot of people, when they watched it, at the end of the episode, they rewatched it again. They thought, oh wow, that was a really cool episode, I'm going to rewatch it again. So this again was unexpected. Prime Video was not planning for this. They didn't think that lots and lots of people are going to rewatch the same episode again right after watching it. Now in both of these cases, Prime Video was able to react accordingly, and they were able to ensure that the people were able to stream the content that they needed. But it was a learning experience. They learned that you need to be measuring what's going on in production, measuring what your consumers are doing, and reacting accordingly and learning from that, because you can't always predict ahead of time what they're going to do. And this brings us back to the mechanisms concept. What Prime Video did is they said, okay, let's take these learnings from production and let's incorporate these into our testing strategy for future events that we will be running. And so this is this idea of continuously improving over time, using a mechanism to improve your process. Another example of an unexpected thing that Prime Video encountered was when they were doing some stress testing in one of their pre-production environments. Now, lots of teams at Amazon have pre-production environments that are replicas of their production environments that you can use for stress testing and integration testing, etc. And on one occasion, Prime Video was doing some stress testing in their pre-production environment, and they were pushing more and more load on their system. But the interesting thing that happened was before they found a problem with their own system, they suddenly started getting throttled by a downstream dependency that was owned by a different team, a different organization actually. And what happened was that the tickets started getting sent to this other team. The team reached out to Prime Video saying, what's going on here? We're suddenly getting a huge amount of traffic from your system that we weren't expecting. And it actually caused problems for that other system. And the learning here was that if you are going to do stress testing, if you do have downstream dependencies that are owned by other teams or other organizations, ensure that you should notify them ahead of time so that they can plan accordingly. And now I want to move on to talking about actual failure injection tests. Up until now, I was talking about a couple of unexpected things that kind of happened, but you want to actually understand what are the kinds of things that could go wrong with your system ahead of time as much as possible. And what you're seeing here are failure injection tests that are used by Prime Video and the magnitude to which they're used. So you can see that they test for things like packet loss a lot down here at the bottom, also latency injection, and things like memory hog, CPU hog. These are the kinds of things that can happen to many systems, especially if you're streaming content over the internet. Things like packet loss and latency are things that you need to be aware of and plan for. And it's not enough to just test for these things. You need to introduce mechanisms to handle them if they occur. And if I go back to the example I was talking about the downstream dependency suddenly throttling their system, what they did in this regard is that they implemented a circuit breaker approach to handle that thing if it ever happened again. With a circuit breaker pattern, what you do is that if you detect that some downstream system is not responding the way you expect it to, or it's not responding at all perhaps, then you don't want to keep hammering that system with more requests. That's not going to make things better. What you want to do is gracefully back off, stop sending requests to that system for some time, and you also want to gracefully respond to your client that sent you the initial request, either letting them know that something is wrong, or else perhaps you can use the last cached version of the last good response that you got from the downstream system, whatever is appropriate for your use case. It's also really important to plan for your high velocity events. We talked about the live sporting events earlier, right? So if you have a high velocity event coming, you need to ensure that you're going to have contingencies and mitigation levers in place. And you also want to make sure that you're prioritizing what are the critical workloads for the intended experience of this event that you're planning for. And if we think about live sports streaming, if you have a bunch of customers watching a live sports streaming event, then maybe you don't need to be recommending other content for them to watch when they're consuming that content. So you want to ensure that your resources are dedicated to serving out that content to them while they're watching that sports game, for example. And you also want to make sure that this is controlled by customer group. So if you have other customers on your platform browsing around and watching on-demand content, for example, you want to ensure that they are getting the personalization and all of the other types of experiences that they're expecting. And this is in line with the mitigating failures section under the reliability pillar. Can any of you guess what are the ones that we've been talking about here? Yes, you guessed it right again. We've been talking about graceful degradation and implementing emergency levers. Now, it's really important to understand that Prime Video didn't come up with all this stuff overnight. They didn't just come up with all these test cases and this test strategy in a really short time frame. It's actually been a multi-year journey that started off with people doing manual load testing of their own systems. And then Prime Video added a dedicated engineering branch to build tooling to automate all of these kinds of tests that we've been talking about. And then this grew over time into communities of people sharing knowledge with each other across the company, sharing feedback to help improve the tooling. And this goes back to that mechanism approach again, right? Where you're constantly getting feedback to improve over time. And now that we've talked about reviewing and testing your architectures, I want to hand you over to Seth again to talk about understanding your systems in production.
All right, awesome. Thank you.
Thanks.
All right, yeah, so understanding services in production that, very much aligned with Amazonian principles that ownership does not end at deployment. It's, Amazon has been practicing DevOps before DevOps was a term. I arrived in 2005 and was handed a pager. And that was before the term DevOps existed. So absolutely the teams are expected to own production. But this is about diving deep and about how leaders operate at all levels, stay connected to details, and audit frequently. So this is not necessarily about any errors in production, but can include that, but it's about how are the services being used in production and how can you improve them to improve the customer experience. And towards that end, I want to start off with a process that happens at Amazon that I think is really important, the weekly ops review. Now, the ops review is led by the SVP, the Senior Vice President in charge of all of consumer. And then the leads from directors and leads from all of the departments are there, as well as representatives from many service teams. It's a big meeting. It used to be a lot in person and a bunch of people online. These days, it's all online. And what happens in this meeting? So number one is success stories and technical talks, right? This is the time to celebrate successes. So-and-so team lowered latency by 50%, so-and-so team reduced errors, whatever. That kind of stuff is definitely important to surface when you have that big an audience there. Reviewing the metrics, that can be part of the success stories. And this is about the metrics of consumer as a whole, of Amazon.com as a whole. I'm going to show you a slide of that later, what the order metrics look like, but those kinds of metrics across all the different marketplaces. And then what can be improved. So there is a COE or correction of error process at Amazon that's really important so that when something does go wrong that's customer impacting, that there's a formalized mechanism, as Kieran talked about, to actually deep dive on not only what are the causes, but what's going to be implemented to prevent those kinds of things from happening in the future. And certainly not every COE is reviewed in this meeting, but a few of the top ones are and discussed amongst the senior leadership. It's a really good opportunity to get exposure for what your team is doing and to learn from what other teams are doing. So in this case, we're going to dive into the best practices, not for reliability pillar, but for the operational excellence pillar, which says, how do you evolve operation? And you can see there's several different best practices around there about learning from what you're doing and making sure that knowledge is distributed and reviewing the actual metrics and things like that. So a lot of good best practices exhibited in the ops review. Now, one of the things that's interesting in the ops review, I don't know if you heard about this before, is the wheel. And the wheel is used to be a physical wheel, but now it's done in a computer program and online. And every tier 1 service in consumer is on the wheel, and the wheel gets spun. And at every review meeting, a team gets to share and go deep on their metrics and what they've been doing. Now, certainly, those metrics and those operational dashboards that they're showing are shown at the local level, at the department level. But this is a chance to show it at the all consumer level. And amongst the things they share are the metrics dashboards. This is just a piece of a metrics dashboard. This is like one little piece that just shows the number of requests and the latencies. A lot more things are going to be on this dashboard, things like availability, error rates, throttling, CPU usage, you name it. And there's also operational metrics like ticket queue and number of high-sev tickets, things like that. So every team at Amazon, the important thing, maintains one of these dashboards with all these metrics on it. So just showing you this one little piece of it, there's the number of requests for some Amazon service. You can see it has a day-night cycle. Again, this is per region. This could be US, or it could be France, or it could be Germany, I don't know. The other thing is the latency. Notice there's multiple latency lines there. So P50 would be the median latency. At Amazon, they don't care about median latency really that much. What they care about is the P99 or the P99.9 latency. What does that mean? So the P99 latency is the latency that 99% of all calls are seeing that latency or better. And by using the P99s or the P99.9s is a truer measure of all the customers. Ultimately a service call does somewhere down the road correlate to a customer experience. So it's a more truer measure of what all or most customers are experiencing than, say, a median. So I mentioned earlier, there's also metrics across the entirety of Amazon Consumer. This is an example of that. This is the orders. The orders are a key performance indicator for Amazon.com. So if something goes weird or wrong with the orders metrics, then it's a strong signal that there's something wrong, all hands on deck. They need to dive into it, and they have mechanisms and processes around that. But how do you know if something's wrong with the order count? If you see here, again, it has that day-night cycle, right? Again, this is for a specific region, whether the US or Japan, I don't know. But it's a specific region. So how do you know if the orders are dropping? They go up and down all the time. Well, it's important that you be able to predict and use anomaly detection. So, for instance, CloudWatch has an anomaly detection capability. That would be a good start in AWS. But here you could see this graph. The purplish lines are the prediction, and there's a range, because predictions have ranges, right? Predictions are never exact. And then the green line, greenish line, the dark line, is the actual order. So you can see everything's within range here, but using that kind of predict capability and that kind of anomaly detection is super important when you're looking at things like your key performance measures, your key KPIs. All right, let's dive into a specific example of another service at Amazon. So Amazon owns Ring. Ring makes cameras, security cameras for home use, doorbells, hence why they're called Ring, motion detectors, that kind of equipment. It's really, really good products. I own them and I enjoy them. So this is their weekly load pattern for their video processing. So someone rings the bell, it takes a video, someone can now look at the video, someone's in your driveway, the motion detection detects that it's a person. Again, you can look at the video. So this is their video processing. You can see it has that same day-night cycle. You can see on weekdays, there's sort of a little double spike there. That's people leaving their home in the morning and coming back at the home in the evening, or more activity during that time. And on the weekends, they don't have that double spike. So AWS and the cloud are perfect for this, right? The elasticity of the cloud. When you need capacity, you spin it up. When you don't need it, you give it back. Ring uses a combination of reserved instances. You can see there's sort of a baseline there. So keeping that in, as your reserved instances, lower prices is good. And then on-demand instances when they need it, when they need to go up in capacity. Oops, I went backwards. Okay, there we go. So now those spikes from the previous graph are what you see like in the middle of this graph at noon. So that's even just a tiny little shallow bump. That was the big bumps on the previous graph. So at the end of this graph, there's like a 10x thing going on. So at Amazon Consumer, they have Prime Day and Black Friday, which just happened. And in those cases, a huge spike is expected. But what do you think Ring's quote unquote Prime Day? It's not necessarily Prime Day. What do you think for this video processing capability, what do you think Ring's big day is? Halloween. Yeah. And this is true. I mean, Halloween wasn't that long ago, and I was out trick-or-treating with my kids, and I kept getting these alerts. There's someone in your driveway, there's someone at your door, there's someone in your driveway, someone in your door. And I liked it. I loved it because, the worst thing is buying a big ball of candy and nobody shows up, right? And especially this year, we didn't know if people were going to show up. So it was wonderful to see all the people showing up and getting the candy. So I really like that. So when you have a big 10x spike like this, and something is predictable, you should prepare for it, and Ring does. They prepare, in advance to know this is coming. We need this extra capacity. And for most AWS workloads, it's a matter of self-service in the console, setting up your reserved instances, making sure that you're ready and you have things in place. If you're a very large-scale service like Amazon.com or Ring, we do recommend you reach out to your account team and make sure that capacity is there so that they can make sure they can accommodate it in exactly the kind of instances you need. But either way, the cloud and AWS can help you with that. All right, so I said this is about video processing. This is what we're talking about, okay? So the one on the left is a situation Ring wants to avoid. This is where I got an alert. This is my driveway, my minivan. Don't be jealous. And I got an alert saying there's some motion in the driveway, and I go to look at the video, and it's not ready. What they want is on the right. You know, you get the alert, there's someone in your driveway, you go there, instantaneous or near instantaneous video processing. That's what they want to achieve. And why is that? Because if there's a bunny in your driveway, you don't want to miss that, right? That's an important event, seeing a bunny in your driveway. It just happened to be there, so I thought I'd share it. And this, again, I love sharing these like simple, it's going to be like a new theme, 4 icon architectures. This is the architecture for video processing. Basically, raw video comes in on the left, gets put into an S3 bucket. That creates an event, which goes on an SQS queue. And then there's a fleet of EC2 instances running their transcoder. That fleet is polling the queue. You got anything for me? Got anything for me? When it gets a job, it then goes to the bucket, gets the video, transcodes it, processes, and puts it in the bucket on the right. That's it. So the key here is how do they scale up and how do they scale down? Well, the cloud offers several ways to do this. They considered, again, they want that near instant video processing. They considered using like queue length, but queue length is an aggregated metric. It's a trailing metric. That wasn't good enough for them. So they came up with their own metric that they're using, and it's empty receives. Think about it. If my workers go pull and they never get an empty, there's always work there. It means work's backing up. If they go there and they're always getting empties, it means that I processed everything, all the work's gone, and then everywhere in between. But it's not as simple as that, right? There's business logic, there's proprietary logic in there. How many empty receives means that we should scale down. How many empty receives means we should scale up. So what they did is they collect those empty receive metrics using CloudWatch monitoring, and they feed it into step functions. Step functions is a way you create a state machine, and that state machine can run lambdas, it can do all kinds of arbitrary logic, and that step function is a state machine that can then process using their proprietary logic. Okay, this is the number of empty receives, that means scale up, so send a scale up signal. This is the number of empty receives, that means scale down, send a scale down signal, and that's how they achieve that near instantaneous video processing. So, okay, back to the reliability pillar, adapting to changes on demand. The question is, how do you design your workload to adapt to changes in demand and use automation and scale up basically when you need it? Those are the best practices from the well-architected framework that we've been talking to you about. All right, final section, going global. So what is the leadership principle here? It's about customer obsession, which is actually the first leadership principle, right? So it's about leaders start with the customer and work backwards. That's a big phrase at Amazon.com, working backwards from the customer. They work vigorously to earn and keep customer trust. Amazon customers are global. They're all over the world. How does Amazon meet the needs of those global customers? Well, that's a place where AWS can really help. And to understand how AWS could help, you look at the AWS global infrastructure. Okay, AWS has 25 regions all over the world, where a region is a multiple set of data center buildings in a specific region. And there's 25 of these. There's 4 being added that were announced. There's one's being added all the time. This number is just going to keep going up. But 25 of those around the world, you can see them on the map there. Within each region are multiple availability zones. An availability zone is 1 or more data centers. Okay, so that's important to keep in mind. An availability zone is not some logical segmentation, it's a physical segmentation. So each availability zone is 1 or more data centers separate from the other availability zones. I can even show you on this last slide there, 1 or more data centers. And the thing about availability zones is they have their own power, or at least their own backup power, and their own onboarding onto the power grid. They have their own separate water supplies. They're located far enough so they should not share fate. They're in separate floodplains. Basically, AWS does a lot of research on like flooding and earthquake, any natural disaster that could happen. They have geologists working on this to put the AZs in places that they should not share fate if a natural disaster happens or if a technical failure happens, like a big bulldozer takes out a big fiber line, right? This means that most AWS workloads can be accommodated with a high availability architecture just using a single region. I want to make that super clear. Using a single region across multiple availability zones, you have high availability. If fire happens, at most 1 availability zone should be affected, the other ones keep operating, and in other talks I have, we talk about how to architect for that. The cases I'm going to show you are a little bit the exception. but they're there in case you need it, which is where services feel they need to go multi-region in order to achieve their goals. And it's not just about reliability. Again, it's about serving a global, worldwide audience. So the first example is Amazon Ads. So Amazon Ads basically is where folks can, put in ads onto the ads platform and expect those ads to show up in various places on the Amazon.com website. And they wanted to go global. They had a globalization initiative. Now, ads is already in multiple regions, but they had a separate isolated stack in each region. Maybe isolated is a little hard, but basically if you created an ad in one region, it wasn't going to show up anyplace else. It was just in that region. And they wanted to find a better way to share. If I put an ad into one region, it could be shared across multiple regions. So as you can see in the last bullet there, DynamoDB global tables to the rescue. So what does that mean? This is the architecture. So now you see 3 different regions. And as ads content, ads artifacts are created, they go into DynamoDB. Now what global tables does is allow you to take a table and replicate it across multiple regions. So the same table exists across all 3 of these regions. And when you write to any of these regions, it is automatically replicated to the other regions. That's the key here. What you also then you see at the bottom, just going down to the bottom where MSK and DynamoDB and Cloud, all the other systems are, that's the old local systems, right? So they don't have to re-architect those. Those systems just see everything as usual. They don't know that something's been replicated in the top layer. So what's that Lambda in the middle there? Well, that's a nice thing, is once you replicate to those regions, it creates an event. And Lambda can react to the event and do whatever kind of business logic you need in that region to make that artifact appropriate for that region. Okay, for my next example, I'm going to refer back to Prime Video, which is something Kieran talked to you a lot about. And Prime Video, similar to ads, it already exists in multiple regions, AWS regions around the world. We didn't want to get into the details of what the specific regions are, so we created our own little fictional map here, and that little blue dot is an AWS region in this, serving this geographic region there, and that's how AWS operated, generally operated for a long, not AWS, how Prime Video operated for a really long time. And so you have a customer down here. They're across the continent, right? So they might have some latency issues. They're not close to the AWS region that's serving their traffic, serving their live playback video. And also, if there's some kind of issue where for some reason, it could be in the data center or it could be anywhere along the network path where that region can't serve that customer is now going to experience an outage. So Prime Video looked at this and said, how do we avoid this? So what they did is kind of similar to ads. Now they can put themselves in multiple AWS regions within that geographic region. This serves 2 purposes. One, as you can see, serving the customer much close to where they are. But the other thing is they architected it so that if one region wasn't able to serve that customer, the other regions in that geographic locality still could. That results in that high availability. So what is our best practices here? Use fault isolation. Deploy the workload to multiple locations. And I want you to keep in mind, multiple locations doesn't have to mean multiple regions. Okay, these 2 examples I gave you had reasons for that, but multiple availability zones is a perfectly fine way to satisfy this best practice. All right, in summary, we gave you a little history lesson on Amazon.com. I hope you enjoyed that. And then we told you how they evolved into this multi-thousands of microservices architecture. Kieran talked to you, he talked to you about that. And then he talked to you about reviewing and testing, about how Amazon uses mechanisms as part of their scalability, reliability strategy, especially using fault injection testing. We talked about understanding how services operate in production and how we use that to best serve our customers. And then we finished it out by talking about the globalization and how you can deploy to multiple regions to meet your customers' needs and how Amazon is doing that. So a couple of resources. We're one of the first talks of reInvent, so we got chock full of resources here. This is the first of 2 slides. The first one's on just well-architected in general. That second link I highly recommend to you, the well-architected labs. I don't know about you, but I learned by doing. So the well-architected labs is a great place where you can go and learn about well-architected best practices by doing labs. Builder's Library is actually not part of well-architected, but it's where those principals and senior principals have written articles about how Amazon and AWS operate. And the well-architected framework white paper is a great place to start for well-architected, and that scan code will take you there. And now, this is the part about being early, right? There's plenty of sessions we could talk to you about. Now, if you want to learn more about Amazon Ads, aside from our 2 slides, you want to see a whole deck about that, go to Under the Hood at Amazon Ads. So they're going to tell you all about that. Then a lot of other sessions here about how Amazon operates internally, the sustainability session, approach to DevSecOps. The ones on the bottom, the INO ones, I recommend those too. The Amazon's culture of innovation and how Amazon transforms experiences using AI ML. I like those innovation ones because they really talk to you more. If you like that history lesson part at the beginning, you'd like the innovation talk, so go to those. Any other talks you'd recommend from there, Kieran?
Not really. I think the ads one would be of specific interest. Jeff Barr, our chief evangelist, just posted something about that this morning, so there's a lot of traction, there's a lot of interest around that. So, yeah, so I think that's probably one to definitely catch if you can.
How do we get Jeff Barr to post about our site?
I know, right? Yeah.
If anybody knows, let me know. And anyway, ultimately, thank you. There's some ways you could reach Kieran and myself. Appreciate your being here. Again, just so thrilled to be here live in front of you all. And before you go, we'll be taking questions. We do not have mic runners, but if you're willing to step up and state your question, we'll repeat it for you and answer your question. Thank you. I stepped on my own applause by saying we'd take questions, but yes, thank you for the applause. But anybody got any questions that they'd like to answer? Yes, please.
How do you simulate a global production load in a pre-production environment?
The question is, how do you simulate a global production load in a pre-production environment? Can I take that one first?
Yeah, sure. Go for it.
So I'd say there's two ways, okay? So it depends on how big is your global production load, or how big is your global system, right? For systems of moderate size, you can stand them up in AWS and be assured that you have something similar size to production. But I think you were hinting at, okay, I can't possibly stand up my entire system, it's too big. And in that case, it becomes tricky. It becomes a math question, right? And when you stand up something that's of smaller size, scaled down, it's not linear that the traffic is linear, right? So it becomes a little more tricky. I will say your secret weapon there is testing in production. Don't go out and do that right away. Don't do that right away. But once you've done your pre-production testing with your scaled down instance, find a time where everybody's all hands on deck. It's a game day. Everybody's manning the consoles. You have a run book with a rollback procedure. Maybe it's night, and then actually do load testing in production. It's a legitimate way to test your production. I'm not saying every month. I'm not saying make it part of your CI/CD pipeline, but it's a legitimate way to test. Yes. How do you manage microservices dependencies? You want me to take it, or you want to take it?
So one thing that we showed earlier is that Amazon has built an internal tool for that purpose that it tracks all services that are deployed and their dependencies between them. But ways that you can use AWS services for this is using things like X-Ray, for example, that tracks all of your API calls. Whenever you're running load on your system, you can use X-Ray to see what services are calling what other services. You can even see what kinds of latency exists between each call and all of that kind of stuff. So what Amazon did is that they took that information and pulled it into a tool that they built to keep track of all of these services and what they're doing. And it's also related to the CI/CD pipelines. When something gets deployed to production, that is registered in the system, and then the systems that interacts with are also tracked accordingly. So, I'll building internal tools and using AWS tools for that also.
I'll add to that. Amazon was bad at that circa 2005, 2010, right? Because we showed you the organic growth, and it was something that Amazon didn't really take into account. And I remember being on a team in 2006, 2007, where we wanted to deprecate a service that was called by hundreds, maybe thousands of other services, and they had no idea who their clients were. That's a problem, right? You can send out all the emails you want saying, hey, if you're a client, we're going to be deprecating, but you're not going to get everybody. So that's not how it is today. But yeah, I think that the pain of experiencing that led to Amazon building the systems that Kieran was talking about.
And just adding on to the previous question that Seth was mentioning about testing in production, when we were showing the Prime Video stuff earlier, we were showing load testing and performance testing, et cetera. They do actually do some load testing in production. Of course, in each region, it would be off-peak when people are asleep or whatever, and when you have relatively low traffic on the system. You don't do it in the middle of the day. But then that's for load testing. You don't do stress testing in production, right? You don't try and break your systems in production. And that's an important thing about chaos testing also. I mean, You know, people often talk about chaos testing as if it's, oh, you know, you just start rebooting servers in production and see what happens. That is not at all a good way to approach chaos testing. When we talked about Prime Video's testing journey, about how it's been this long-term, multiple-year thing, they didn't come up with it overnight, they didn't start doing chaos testing in production. Basically, you do all of the stress testing and failure injection testing in your pre-prod environments as much as possible.
Yeah, another thing I want to add is Amazon.com does load testing and stress testing like Kieran was talking about. Specifically, all teams are expected to test in pre-production to the breaking point and measure how long it takes them to recover. That's actually one of the metrics of the stress tests.
All right.
Other questions? Anybody?
Oh, there's one over here.
All right.
How do you advise doing multi-region when you're serving terabytes of data with different Amazon Web Services, like Dynamo as well as S3?
How to do multi-region when you have terabytes of data? Well, I mean, there's a trade-off, right? And doing multi-region doesn't mean all data is copied everywhere. All right, so you can do multi-region where only a select set of data is copied everywhere, maybe some of the metadata, but some of the customer data is stored in a certain region, and when you need to read it or write it, you can route your reads and writes to that region. That's a partitioned approach. You could even for some, so that's one way to do it. I mean, AWS will give you native tools to replicate that data. DynamoDB global tables, S3 cross-region replication. The question is, you know, do you want to actually send all that data over the wire, or can you pick a subset of it? And I think, you know, the tools are there, and it'll work with terabytes of data. It would just be costly.
Yeah, the cost is the cost trade-off. That's the thing. So you need to determine: do you need to replicate all of the data? Is there data that's hot in different regions, and then for colder calls you can go cross-region, for example. So yeah, it basically comes down to the workload. Whether you need all data replicated or just some of it.
Any more questions? We love the questions part. Yes?
What kind of tools do you use or use in this case, right? For testing, for monitoring?
Oh, what are the tools for testing and monitoring? So the funny thing about working at Amazon.com is the great stuff you get in AWS actually started off usually as Amazon.com tools that were then, people said, this is cool, let's externalize it. So in a lot of ways, Amazon.com uses plenty of AWS, don't get me wrong. But a lot of these internal kind of tools tend to be different than the AWS tools, the homegrown tools that then ultimately become the AWS tools. And then it's hard to get everybody migrated onto the AWS tools. It's just, you know, it's working, why do it? And it does, but it does happen. Case in point is monitoring. Like Amazon had its own internal monitoring systems. CloudWatch came along, now it's all CloudWatch. Actually, it's even better than that. The old monitoring portal is still there, but it's all CloudWatch under the covers. So, but if you want to do fault injection type testing, then FIS, the fault injection simulator, is going to be a great option. I actually have a workshop about this afternoon. That's a native AWS service, and there's lots of other commercial and open source products. Chaos Toolkit comes to mind out there for doing that kind of fault injection testing. Anything to add?
No, I think you captured that one well. Yeah. It's mainly CloudWatch, but originated from internal systems that Amazon had built.
And that was one of the things Kieran talked about onboarding. So I'll get to inside. Prime Video created their own internal frameworks for fault injection testing and monitoring that testing, and then getting everybody to adopt it was part of the cultural challenge. Yes?
Yeah, so you talked about the non-services, but eventually every AWS service has some kind of soft and hard limit. So what if you hit the hard limit on that specific workflow? How do you handle that?
Well, the question is, every AWS service has soft and hard limits. What happens when you hit a hard limit? So I guess there's two kinds of hard limits, right? Because there's limits you can increase yourself using quotas, Amazon AWS quotas in the tool. Then there's limits that you need to contact your account team for. Those are sort of like the medium hard limits. And then there's hard limits. There's just nothing more than that. I don't, I'd have to talk, that's a case-by-case thing, right? How do you architect around that? I mean, we're not talking about number of EC2 instances, I don't think, right? I mean.
No, because if you have, for example, you show Lambda or anything else, then you have like millions of users that try to access the same service right now.
Yeah. Mm-hmm. So yeah, what are the concurrency limits on Lambda? Do they tap out at a certain hard limit?
Yeah, they do. And so it's also important to remember that limits are per Amazon, per AWS account.
Yeah.
So we do work with lots of very large systems in Amazon that span across many, many accounts, some of them across hundreds of different AWS accounts. And you can use things like AWS organizations to share things across accounts and all of this. But it gets pretty complex at that point. Once you need to go beyond a single account, then there are ways to architect for using services and sharing resources across accounts, et cetera. It does get pretty complicated.
All right, I think we're out of time. By the way, you folks that stayed for the questions and answers, you're the smart folks. It's the best part of any talk. It's when you learn the real stuff. So appreciate your staying, appreciate you being here. Thank you so much.
Thanks, everybody.